Hello and namaste everyone. Welcome to my channel Engineer Star. My name is Sanjeet Thapa Magar. Today in this video I will solve the numerical of design of roof truss of steel structure. First question that was asked in 2019 Purbanchal University is design a I-section purlin for a roof truss located in Biratnagar. Spacing of the truss is 6 meter. So the truss will be like this is the steel truss and this is the 3D diagram. The purlin is the horizontal member. Which is of I section for a roof truss located in plano. Spacing of truss. This is one truss and this is another truss. The spacing of truss is 6 meter. 6 meter. Spacing of purlin along slope. This is slope, so spacing of purlin along slope is this distance is 2 meter. Spacing is also denoted by yes. Slope of roof is 1:2. That is this is roof and the vertical is 1 and horizontal is 2. Wind load on roof surface. This is roof surface and wind load on this roof surface is this 1100 Newton per meter square, and vertical load from this roof is this vertical is 200 Newton per meter square. So given is spacing of truss is this 6 meter. Spacing of purlin along slope is this distance, which is 2 meter, and slope is this 1:2. So slope of roof is tan theta. Slope of roof is denoted by tan theta, which is equal to vertical by horizontal, that is 1 by yacht. So theta is tan inverse of 1 by 2, that is 26.6 degree. Wind load on roof surface is 1100. Wind vertical load from roof sheet. Vertical load from roof sheet is 1200 Newton per meter square. In this question we have to assume there is no hard and fast rule, so we have to assume any, but we should assume this to be more so that it will be safe and we do not need additional trials. So let us assume ISLV 125 at the rate 11.9 kgf per meter as purlin. So this is a purlin, which is beam that is made up of I section. Dead load on purlin per meter. So weight of roof sheet. This and this is roof sheet. So dead load of roof sheet is in here. Dead load is 200 Newton per meter square multiplied by this spacing yes. which is in per meter. That is 200 into spacing just 200 into 2, 400 Newton per meter, and self weight of roof is 119 Newton. So 119 is this. So this is the kg of its unit of weight. So weight is the force exerted by mass of 11.9 kg. Since it is the force exerted by mass of this, so we need to multiply by g to convert mass into force. So 11.9 and g is 9.81 meter per second square, but we can approximate it at 10. So 11.9 into 10 is 119. Weight is 119. Where is weight? 119 Newton. The unit of force is Newton. So total vertical load is this of roof sheet and this of I think purlin. So total weight is 400 plus 119 is 519 Newton per meter. So wind load per meter length. Its wind load is 1100 Newton per meter square and multiplied by S, that is 2, is gives Newton per meter. So for this purlin, this is purlin beam and the truss is support. And for this continuous type of beam, the formula is W L square divided by 10. So W is the beam for here. The I section will be like this. So this is from horizontal theta, horizontal. So from horizontal it is 26.6 degree and the I section is resting here. So this W1 is wind load which acts perpendicular to the roof, and this is W2. W2 is total vertical load. So let this is x-axis, so in moment in x direction it is W1 plus since this is theta, so this is 90 minus theta and this is theta, so this is also theta. So the weight component of this W2 in this direction is W2 cos theta. So the bending moment formula is WL square divided by 10 in this case of continuous purlin. So W is W1. W1 is this, and W2 is component of weight in this direction, which is W2 cos theta. So we get mx 9590.6 Newton meter, and my this is y direction. So in y direction, component of W1 is 0, and this component of this W in this direction is W2 sin theta. So W2 sin theta L square divided by 10. So my is this. So for ISLV 125 from steel table, ZX is 65.1 centimeter cube and ZY is 11.6 centimeter cube. To convert centimeter into meter, we multiply by 10, and since there is cube, so cube. So maximum fiber stress is mx divided by zx plus my divided by zy. Mx is this 9590.6 into 10 to the power 3, and my is 836.59 into 10 power 3, and zx is this 65.1 into 10 power 3, and zy is 11.6 into 10 power 3, and the unit is Newton and so unit are same, so it will be in megapascal. From section 6 of IS 800 1984, maximum bending stress is 0.66 of Fy, that is 250 in our case, so which is 165. So maximum bending stress should be 165, but the maximum fiber stress is 219, which is very greater than this, so not okay. So we have to let us assume ISLV 250, because 250 is the depth of 250 is more than this 125, so the Z value will be also more. So ZS is 297.4 and ZY is 30.9, which is greater than this 65 and 11.6. So dead load on Portland per meter is weight of roof sheet is 400 as in previous, but self weight is 279, that is 27.9 into approximate 10, that is 279 Newton. So 400 plus 279 is 679 Newton per meter. So W1 is given in question 2200. Mx by this formula we get the value of mx and my. So maximum fiber stress is this mx and this my, and zx and zy value are this. So by doing some maths, maximum fiber stress is 69.4, which is less than 165 megapascal. So okay, so we provide ISLV 250 at rate 27.9 kg of per meter as pore length. So this is the next question asked in 2018. So for wind load, we use IS 875 part 3 1987. Determine the maximum wind pressure to be considered on a sloping roof with the following data. Base wind speed is 47 meter per second. K1, K2 and K3 are given. So from clause 5.3 of IS 875 part 3 of 1987, the formula is given. Vz is Vd into K1, K2 and K1, K2 and this is K3. So K1, K2 and K3 all are 1. So Bz will be Vd, which is 47 meter per second. So the wind pressure for this wind speed is 0.6 Vz square. So 0.6 into 47 square is 1325.4 Newton per meter square. And this formula is also given in clause 5.4 of IS 875 part 3 1987. So CPI is plus minus 0.5 for all case. CPI is plus minus 0.5. Here also plus minus 0.5. And the value of CPE is wind normal to the ridge. This is ridge line in 3D. If this is truss, then this is ridge line. So wind normal to ridge. So this is ridge, so normal to ridge is this direction. In windward direction, if wind flow from this to this, it is called windward direction, and this direction is called leeward direction. For windward slope it is minus 0.4, and for leeward slope also it is minus 0.4. So first case, when wind blows normal to the ridge for both windward and leeward position, CPI is plus minus 0.5 and CPA is minus 0.4. So the pressure, this formula is given in clause 6.2.1 of this IS code. There the formula is given by F is P E minus C P I into A into P D. So this force divided by this area is this pressure, which is equal to CPE minus CPI into PD. CPE is minus 0.4 for both case, and CPI is negative of plus minus is also plus minus, so 0.5, and PD is this 1325.4. so taking positive sign, pressure is 132.54 Newton per meter square, and taking negative sign, pressure is minus 1192 plus 0.86 Newton per meter square. And second case is when wind blows parallel to the ridge. When wind blows parallel to the ridge, so this is the ridge and parallel to ridge is this direction. In here this is this direction, and for both slopes for 1/4 length of building, the value of CPE is minus 0.7, and for both slopes of middle half length of building, the value of CPE is minus 0.6, minus 0.7 and minus 0.6. for this it is minus 0.7, and for this case it is minus 0.6. so from this formula CPE is minus 0.7 and minus 0.6, and CPI is plus minus 0.5 for all cases, and PD we have calculated 1325.4. so taking plus positive we get this, and negative we get this, and here taking positive we get this value and negative this value. So maximum downward pressure is maximum value, or maximum positive value is here. It from these two maximum is 132 and it is less than 132. This is also less than 132, so maximum positive is 132.54 Newton per meter square, which is downward pressure. To calculate upward pressure we have to calculate the negative, highest negative value is this is minus 1192. 1590 is highest, so 1590 is highest negative value, which is upward pressure. So it was asked in 2017 in Purbanchal University, 5A, in only 6 marks. So determine the maximum wind pressure to be considered on a sloping roof from the following data. Basic wind speed is 50 meters per second, and K1, K2 and K3 is 1, 0.85 and 1 respectively. So 50 multiplied by 0.85 is 42.5 meters per second. The design speed is design wind pressure PD is 0.6 meter square. 0.6 into 42.5 square is 1083.75. When the wind blows normal to the ridge, CPI is plus minus 0.2 for both cases, and CPE is when wind blows normal to the ridge in windward slope, that is 0, and leeward slope minus 0.4. CPE is 0 in windward slope and minus 0.4 in leeward slope. In windward slope 0 and leeward slope minus 0.6. so CPI is plus minus 0.2 in all this case. So taking positive sign we get this, and negative sign this, and similarly taking positive signs we get this, and negative sign this. Maximum downward pressure is the maximum or highest value is this 26.75, and maximum upward pressure, that is lowest value, is minus 650.25 Newton per meter square. And this question was asked in 2016. Design a I section purlin. We have to design an I section purlin for a truss roof from the following data. Span of roof is 12 meters. It is the truss roof. So span of roof is 12 meters. Span is the distance from here to here. It is 12 meters. 12 meters. And spacing of truss. spacing of truss is 5 meter. Spacing of purling along the slope. This is the slope, so spacing of purling along the slope is what is this? I think it is 2 meter. 2 meter, and slope of the roof is 1 vertical, 2 horizontal. That is slope. So for 1 vertical, horizontal is 2. And wind load and vertical load are also given. Slope is tan inverse vertical by horizontal. Tan inverse 1 by 2, that is 26.6. Assuming, we have to assume this by random heat and transfer method, 125 at rate 11.9 kg per meter to be used as purling. Dead load of purling is weight of roof sheeting is 200 Newton per meter square. So 200 into this spacing 2 is 400 Newton per 1 meter length. And self weight is 119 approx. So 119 into 9.81 is around 1.119 approx. Total vertical load is this 400 plus 119, that is 519 Newton per meter. Wind load per meter length. So wind load is 1000 Newton per meter square, and for per meter length it is for per meter length, wind to multiply by this is also 2 meters, so multiply by 2 is 1000, multiply by 2 is 2000, and by this formula and this formula, mx and my are calculated. Zx and zy from this IS 129 is given in steel table for I section. So from this formula, maximum fiber strength is mx by zx plus my by zy, that is 114.7, which is greater than this. I think this is 0.66 into 250. Yes, for bending, maximum permissible stretch is 0.66 into Fy. So in Fy, if not given in question, we have to always assume 250. So 0.66 into 250 is 165, and this value should be greater than maximum permissible stress. So okay. And this question is asked in 2015. Determine wind pressure to be considered on a sloping roof from the following data. Basic wind speed, that is BB, is 47, and span of roof is 12. Span is 12. If this is roof truss, then span is from here to here, which is 12, and pitch is 1 divided by 4. Height of eaves above the ground. So height of eaves above the ground is meter, and K1 is risk factor, which is 1. K2 is terrain height or structural size factor, which is 0.85, and K3 is topographical factor, which is 1 given in question. So K1, K2 and K3 are 1, 0.85 and 1 respectively. So Vz will be 39.95 meter per second. Design wind speed PD is 0.6 of 3.9 39.95 square, that is 957.6 Newton per meter square, and pitch is span divided by pitch is rise. This is rise divided by this span. Rise is not given, but span is 12 given in question, and pitch is 1 divided by 4, so rise will be this 3 will go here, so rise will be 3. And slope of roof is alpha, which is 10 inverse rise divided by span by 2. To calculate pitch, the pitch is this rise divided by this whole span, but to calculate this alpha, the slope is alpha is from horizontal, so slope is this vertical rise divided by only this, which is span divided by 2. So slope of roof is 26.56 degree. So lesser horizontal dimension of the building. Lesser horizontal dimension of the building. So this is greater horizontal and this is lesser horizontal, which is 12 given in question. And height of build is also 6, that is height of eaves above ground, that is height of this, which is 6. Building height ratio is H divided by W. 6 divided by W is 1 by 2. So we have to find design wind speed, wind pressure on the sloping roof for two conditions. So condition 1 is when direction is normal to the ridge. Normal to the ridge means this is the plan or top view, and this is the ridge, is the topmost part, which is this topmost part is this is ridge. So first is normal to the ridge is this direction, and parallel to ridge is this direction. For theta is it's equal to 0 degree. When theta is 0 degree, it is this direction, so it is normal to the ridge, and when theta is 90 degree, it is this direction, so it is parallel to this ridge. So this figure or this EFGH is given in this code. So the side line is called eaves and middle line is ridge. So span of this is truss. Span of truss is 12 meter, and for windward side, when theta is 0, that is perpendicular to ridge, in windward side, then wind flows from here to here, so windward side is this EF. This EF. Our value of H by W is 6 by 12, that is 1 by 2, which is less than or equal to 1. So from this table 5 of page 16 of IS 875 part 3 1987, and for this roof angle 26.56, which is in between 20 and 30, the value of CPE are minus 0.4 and 0. So by interpolation, this CPE we get minus 0.137, and the value of CPI is not given in question. So we assume wall opening as less than 5%, that is normal permeability, and for normal permeability CPI is plus minus 0.2, which you can find it in clause 6.2.3.1 of this IS code. So combined external and internal pressure is given by this formula. So when positive it is 60.33, and taking negative value it is minus 22.7, and this is the case for windward. And for leeward side, when wind blows from this to this direction, the leeward side will be this side. So this side is G yachts. Yachts by W is less than 1 by 2 and angle theta. So the value of CPE are minus 0.4 and minus 0.4. So the alpha for this will also be minus 0.4, and CPI we assume from this normal permeability CPI is G plus minus 0.2. So combined external and internal pressure is taking positive sign it is 191.52, and taking negative sign here it is 574.56. and the B is when the wind direction is parallel to the ridge. So when theta is 90 degree, the wind direction will be this, which is parallel to ridge. For windward side is this side, so EG side. EG side theta is 90 degree, and for this slope from table CP is in between minus 0.7 and minus 0.7, that is minus 0.7, and CPI I have already told. So combined external pressure will be this. For leeward side, when wind blows from here, the leeward side will be this side, which is FG. Leeward side is this F yachts. So the value between minus 0.6 and minus 0.6 is of course minus 0.6. So combined external and internal pressure is this. So design wind pressure for uplift should be negative. Highest negative is minus 766. Minus 861 is more than that previous. So highest negative is this minus 681. So taken point it is minus 861.84 Newton per meter square, and design wind pressure for downward means maximum positive value is .33 Newton per meter square. Hope you enjoy the video. So thanks for watching. Like, share and subscribe the channel. If there is any doubt, then you can tell me in comment section. Thank you.